Now, with this topology, we are going to understand a few more things that we have in RIP pending. One is the terminology called split horizon rule, route poisoning. The third one is Poisson reverse. Three terminologies that we are going to see with the help of this topology. So now, what is that split horizon rule? On every port, routes are learned. For example, about this network, on this port, the update comes and this router learns that 30 network is one hop away via G000. And then on this port, it learns about this network as one hop via G0/0/1. This port. So we are learning routes, different route on different port. If this route goes to the same router from where it comes, that is unnecessary as well as that is not correct. I repeat, this 1111 update coming here is correct, acceptable. But that same 111 network, if it goes back, first thing is it is unnecessary. Second thing, it may cause confusion. How? It received as one hop. When it goes back, what it will do? It will say, hey, for me it is one hop, for you it is two hop. Then router C will say, no. I have directly connected 1111. It is zero hop for me. Then why should I accept your update? You're giving an update with a bigger metric than what I have. I have a 0. You're giving me 2. Metric smaller is better. So router C will say, no thanks. So it's a waste of sending the update to router C. About 1.1.1.1. Same case. On this direction, if router B says 30 network is 2 hop, that is also waste. Now let us say someone offed this computer. Offed. So the link will go down. Immediately this router, in the routing table, it will remove this router this was the root. But as soon as this link goes down, this gets removed. The 30 network is already down. But this guy has already learned. This guy has already learned the route, no? What this guy do? It says, hey, 2 hop for you. Then RA, there is a chance of RA learning it. RA will learn the update coming from coming from RB, which is not true. The original owner is this guy. Now, the original owner itself is confused because the directly connected network gone down and the route from the routing table got removed. As a result, when someone gives that route, that someone learned from RA. But now RA don't have the root. When someone gives that root, when RB gives the root, RA thinks that RBA also may have a connection to 30, so it learns it, which is no way true. Router B is no way connected to RB, 30 network in any way. RB is no way connected to 30 network. But RA thinks now that it is there with RB. RA thinks that it is there with RB, which is wrong. So what will happen when a packet comes? When a packet comes for the destination 30001, what this router will do? It will send it to router B. And what router B will do? It will send it to router A. Again, router A will send it to B. A loop occurs. To avoid these things, to avoid all this confusion, this should not happen. What should not happen? Going back to the original source is not correct, need to be avoided. Router B should not talk about 30 network to router A. If it talks, loop occurs. If it talks, wrong information gets conveyed. If router B learned 30 from router A, if router B learns 30 network from router A, it should only give to C, not to A. This is achieved by a rule called split horizon rule. Split horizon rule. It is achieved by a rule called split horizon rule. And that split horizon rule is acting on this port. Also on this port. Also on this port. Also on every port of Cisco routers enabled with this particular feature called split horizon rule, even when you don't have RIP protocol. Even when you don't have, even before you enable RIP, this rule is active, working. I want to show you that. First, let me take one fresh router and show you, because these routers are already running RIP. You should not think that this split horizon rule is only for RIP. No, for RIP, this is a gift for RIP. RIP no need to do anything to avoid that loop. That split horizon, which is already running, takes care of it. But this topic is mostly taught in the RIP topic, under RIP. So you should not be in an impression that this topic is a RIP topic, the routing protocol RIP topic. No. I want to show you even before. So I did not get it, what you said. What I'm saying is split horizon is enabled on every port, on every router, whether you have RIP or not. You understand now? Okay. That is what I want to show you. You see in this picture, we are having this newly added two routers. I just added and I gave IP address 10.0.0.1 and I'm going to give 10.0.0.2 and show you split horizon works. I will not enable any RIP. Even though I don't have RIP, what will be there? Split horizon should be there. On this router, RIP is there. The reason why I added this new topology is, you should not think that the split horizon is enabled because of RIP. That's why I added new topology. Now let me go to this router also, bring the interface up, and then I'll show you split horizon.
So, sir, that means split horizon is helpful in other routing protocols also.
Yeah, in every routing protocol, especially in distance routing protocol, distance vector, both in EIGRP and in RIP, split horizon is helpful.
Okay, thank you.
Welcome. Right now, you see, even in OSPF, split horizon is helping in with every routing protocol. We should know that split horizon is there, taking care of sending update to the original sender, originator. Now, you see, the interfaces come up, and these routers don't have any RIP. You see, show IP protocol. There is no routing protocol running, but I'm going to show you the split horizon now. Show interface. That's the command. Show IP interface. I should say IP interface. Show IP interface. Gig 000. Look at this. I did not enable this. It is working already. And there is no RIP in this router. There is no RIP in this router. But split horizon is running. Okay, now I'm going to remove this and show you split horizon on this router as well. Obviously, it will be there because it is there by default, whether you have RIP or not. Show IP protocol. Here we have RIP, and this RIP uses infinite metric as 16 to prevent loop, but that loop is already prevented by split horizon. Then you may ask, then why that 16 hop? See, to prevent loop only, RIP is limited to 16 hop. If in case loop occurs, it won't go. The metric, if it reaches 16, the route will get removed from the routing table. If metric of any destination, if the metric of any destination reaches, any network reaches 16, it will remove the route. Whenever loop occurs, see, if someone disables split horizon, someone is disabling split horizon here. So what will happen? This 30 network is advertised with one hop. Because you have disabled, it will also come here and say 30 network is 2 hop. But router A won't accept it because 30 network is directly connected. It won't accept it, but update will be coming. The reason is split horizon is disabled. The update will come inside the port, and router will see the metric and say, no, I will not accept it because I have a better metric 0. But when this network goes down, router A will learn it. Router A learns this 2 hop. Now router A will give this router, because split horizon is disabled here also, it will give this router saying, for me it is 2, for you it is 3. then this router will think, okay, router A was the one who gave me this. Now he is giving 3. So let me change it as 3. And then it will advertise as 4. This will advertise as 5. Again, this will advertise as 6. It will go up to 15. And then it will advertise 16. And this guy will reject it. That's why that infinite metric 16 is set, so that accidentally or intentionally, if someone disables split horizon, loop can be prevented, because the number 16 as the metric is a poison metric. They don't like that metric. They will reject those updates coming in that will prevent loop. But the good news is that 16 we don't use to prevent loop. That split horizon itself prevents the loop. Only if someone disables split horizon. See, I can disable and show you. That's it. I can disable. If someone disables, problem. But RIP solves the problem by saying, I will only accept when it reaches up to 15 hop metric. After that, I'm going to discard it. So loop will be Loop will be there only for few minutes. Every 30 seconds, hop count will be incremented and sent. When it reaches 15, it starts sending 16. And the receiving router will say, 16, I don't take. 16 hop, I don't take. So, what is the loop prevention mechanism in RIP? Answer is IP split horizon. But if split horizon is disabled, what is the loop prevention mechanism? Hop count. Infinite metric is the loop prevention mechanism. RIP supports only 15 hops for this reason. In case if someone disables split horizon, if loop is going to occur, it can be stopped after some time, because when the metric is getting incremented for every loop, it won't go beyond 15. So we have learned what is split horizon rule. What is split horizon rule? Routes that are learned on a port should never be advertised back on the same port. Route that are learned on a port, for example, if 1.1.1.1 is learned on G000, that same 1111 should not go. Do you have any question on split horizon? I'm sorry, what did
No,
you
sir.
No? Okay. What is next we are going to learn is route poisoning. Route poisoning. You see, about this network 30, router A will advertise saying 30 network is 1 hop. B learns it. And now B will advertise it saying 30 network is 2 hop. And C will learn it. Okay, I'll ask you a few questions now. Is this 1 and 2 valid metric or not? Are they valid metrics? Please answer no, yes or no. Only if it reaches 16 it is invalid, right? Is it not valid? 1 and 2? It is valid. We are trying to understand a topic called route poisoning. Route poison. You see, after advertising, this network went down. So, this advertisement, which is every 30 seconds, stops going. RIP used to send update every 30 seconds. But because the network has gone down, it has stopped. It has stopped saying about 13. But these two routers are still holding the route. How long this will hold? You know the hold time. This will hold for 180 seconds. But how many 30 seconds is there in 180 seconds? 6 30 seconds are there. 30 seconds. How many times of 30 is 180? 6. So in that period, this will be keep on advertising to this neighbor. I want to repeat and make it very clear for you. Even though the network update is not coming from A, B will still keep on saying every 30 seconds. And keeping track of this timer. Once it reaches 180 seconds, listen carefully, this place is very important. Even though it is not receiving, it is still giving. Every 30 seconds, about this 30 network has two hops. But after reaching 180 seconds, what it does is it says possibly down, and immediately it is not removing the route. You know why? Because it has to warn the downstream. So it puts 16 and send to C. The moment router C sees 16, it makes it as possibly down. Look at this. Immediately. B has already waited. So C no need to wait again. So what B is doing is, it says, it's my responsibility to alert C. I already waited 180 seconds. I discovered that it is possibly down. So I need to alert C. How it alerts? Instead of sending 2, it sends 16 now. After 180 seconds, it says 16. So that this will know that the early route that we got is possibly down. Now, after reaching possibly down, they will wait for 60 seconds and they will remove it. This is what called as route poisoning. It has poisoned the route after knowing that the route is no more exist. So that no one will drink that poison, you see. When the route is not available, why should someone forward the packet? After knowing it is down. B waited. And C again, it need not to wait. So B alerts by sending a poisoned route. After seeing that poison in it, 16 is the poison. Earlier it was 2 hop count. Now it is 16 hop count. Then C says, oh, this route is no more available. I am going to remove it. If C is connected to D, it will immediately send 16 hop to this guy also, so that this guy will also remove after 60 seconds. So after this network went down, it is only totally 240 seconds for everyone to remove. In that topology, in 240th second, all will throw the route out. So what is route poisoning? After knowing a network is down by waiting 180 seconds, advertising the downstream routers with a hop count of 16, so that the downstream routers will also know that the network is no more available, is what called as route poisoning. Sending with 16 hop is what called as route poisoning. Did you understand route poisoning? So now we understood route poisoning, that router B, after waiting, it will send 16 in the place of 2. Earlier it was 2 hop, now it is sending 16. That is route poisoning. If the same thing happens backward, usually split horizon will not allow to say backward. But after waiting for 180 seconds, split horizon will allow. So it goes back to the original sender with 16 to make sure that it is truly down. See, if this router, the original sender, has this 30 alive, for this it will object. It will say, no, 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 it's not 16 up. It is directly connected to me. It is 0. It will object. But because the network is truly gone down, the original sender will not reply anything. This is what called as poison reverse. Reverse. Because it is coming reverse to the sender after 180 seconds with a 16 hop to cross check, to make sure that it is truly gone down. Going towards the downstream is route poisoning. Coming to the upstream to confirm is poison reverse. Coming back with 16 hop to the original sender to confirm is poison reverse. Going with 16 hop after waiting 180 seconds downstream to update them is poison reverse. Is that clear?
Yes, sir.
Have we done labs with version 1 and version 2?
I did some only one I lab I did, I think.
Okay, no problem. I'm going to do it one more time. You see, we have 3 routers. And when I enable version 2, the multicast address will be used to send the update. When we use version 1, it will be broadcast. Let's see what version we have. Show IP protocol. Version is 2. Which means when I say debug IP rip, I can see what is debug. Digging deeper. Generally, the updates that is going between the router every 30 seconds cannot be seen. Do you see any update going? No. But when you say debug IP rip, it will start showing all the RIP conversations. Generally, it won't show, but after saying debug, it will show. I'm putting this debug to show you that version 2 will use 224.0.0.2 multicast address. You see? Sorry, 224.0.0.9 multicast address. And it will also advertise the subnet mask. Version 1 will not advertise subnet mask. Version 1 will be sending it to a broadcast address 255.255.255.255. You see the updates are going with the hop count metrics. Yeah. So now I'm going to stop this. Because I have RIP on all 3 routers with version 2 enabled. Here also version 2, and also on C version 2. Everywhere version 2. Now if I check the routing table show IP route, I can see the RIP routes. R means RIP. Route learned via RIP. It shows that this 1112, where is 1112? It's here. Router C routing table says that 1111.2 is one hop away. And what about the 30 network? 30 network is 2 hop away. That's true. Going to B is 1 hop. B to A is 2 hop. That is where you have 30 network. Yeah. Now, I can ping the 30 network. 30.0.0. What is the IP address on the PC? It's 1. You see, I'm able to ping. 5 packets sent and 5 packets received. Success rate is 100. So this is how the protocol RIP works. It uses split horizon. It uses the infinite metric 16 to alert by sending poisoned route after waiting 180 seconds. But it overrides the split horizon rule whenever a network is found possibly down. It goes to the original sender to reconfirm. With the 16 hop, it goes, we call it as poison reverse. And we also learned what is split horizon. A route learned on a port should not be advertised back on the same port. Right? And we also saw how to configure RIP in the previous class. I can show you again. I'll completely remove from this router, no router, RIP. Okay, no router RIP. Forget about it. I removed the RIP. Show IP protocol. You see there is no protocol. And if I ping that, the ping won't happen because I removed RIP. Just to remind, I'm configuring once again RIP on this router. This router has got 2 networks, 20 and 1. So I'm going to say router RIP version 2, network 1, network 20. And because we have subnetted networks, you say no auto summary so that it won't summarize and send. It will send the detailed subnets. By default, it will summarize to classful boundaries. We say no auto summary. Now after this, when I take you to the routing table, you will see the routes again. Now if you ping, the ping will happen. All right. Are you comfortable with RIP, the topic RIP?
Yes, sir.
All right. So